let n be a positive integer such that 2n has 8 positive factors, 3n has 12 positive factors. All right, determine all possible numbers of positive factors of 12n. Therefore, I think how do you get 8 factors? That means case number 1. We can assume that 2n is actually p to the power 7. Then obviously p is a prime. P is a prime. Okay, because you know why? If you look at this number of factors, that will be just equal to what? The number of factors will be just equal to 7 plus 1, and that will give you 8. Fulfill the criteria. But the thing is, when you say 2n equal to p to the power 7, it actually implies that this prime is actually 2, right? That means your p has to be 2. All right. That means in this case, 2n will be just equal to 2 to the power 7. Therefore, n will be just 2 to the power 6. 2 to the power 6. But now we look at 3n. 3n will be just 3 times 2 to the power 6. Then what is the number of factors? Number of factors now is actually number of factors. Can you say that this is 3 to the power 1? Therefore, it is actually 1 plus 1 multiplied by 6 plus 1. Right, which is actually equal to 14. And 14 is not equal to 12. Therefore, in this case, this is an impossible case. Therefore, case number 1, no solution. Case number 2, that means actually 2n cannot be equal to p to the power 7. Therefore, now your 2n is actually the product of two fractions, two primes, which is p to the power 3 and q. Because and then obviously p and q are distinct prime. I need to emphasize they are distinct primes. Distinct primes. Okay, because you know why? The number of factors is actually 4 plus 1 multiplied by 1 plus 1, which is 8. Therefore, this is correct. Okay, therefore, now we can assume that suppose I let q to be 2, because there's a 2n here. Then in that case, your 2n will be just equal to p cubed times 2. Right? Therefore, n is actually equal to p cubed. N is actually equal to p cubed. Then can I say that suppose suppose your p is actually 3. All right. Then your 3n will be just equal to 3 times 3 to the power 3. Okay, that will be 3 to the power 4. And the number of factors in this case is just equal to 4 plus 1, which is equal to 5. And this is not equal to 12. It doesn't fulfill the criteria that 3n has 12 positive factors. Therefore, this is not possible. Right. Therefore, now we know that p has to be greater than 3. P has to be greater than 3. That means now can you see that your 3n would be just equal to 3 times p. 3 times p cubed. Right, and then the number of factors now would be just 1 plus 1 and then 3 plus 1. And then again, it is equal to 8 and cannot be equal to 12. Therefore, again, no solution. No solution. Therefore, I think maybe, okay, yeah. Right. Therefore, now it can be the other way around, right? Therefore, in this case, it can be the case whereby p is equal to 2, and then your q is actually 3. Therefore, what does it mean? That means your 2n is actually your 2n is actually 2 to the power 3. 2 to the power 3, and then your q is 3. All right. Then your n is actually 2 to the power 2 multiplied by 3. All right. And then in this case, can you see that the then your what is your 3n now? Your 3n would be just equal to 2 to the power 2, and then this is 3 to the power 2, right? Because there's 3 to the power 2. Therefore, in this case, can you see that this would be 3 to the power 2. All right. Then number of factors would be just equal to 2 plus 1 multiplied by 2 plus 1, which is equal to 9. And again, this is not equal to 12. Therefore, this is not possible. Therefore, now we know that your P can be 2 and then your Q must be greater than 3. Must be greater than 3. Therefore, your 2n is actually 2 to the power 3 multiplied by Q. Therefore, your n is actually 2 to the power 2 multiplied by Q. Right? And then your 3n now would be 2 to the power 2 multiplied by 3 multiplied by Q. Therefore, number of factors. That will be just equal to what? That will be 2 plus 1 multiplied by 1 plus 1, because this is 3 to the power 1. And then your Q is actually 1. Therefore, 1 plus 1, and it is equal to 12. Yes, it fulfills the criteria. If fulfill the criteria, then I can move on to find the number of the possible numbers of positive factors of 12n. Therefore, in this case, now we look at 12n. 12n will be just equal to what? Take note, 12n is actually, okay, this is actually 3n, right? It's actually 2 to the power 2 multiplied by 2 to the power 2 multiplied by 3 to the power 1 and q to the power 1. Therefore, what you get is actually 2 to the power 4 multiplied by 3 to the power 1 multiplied by q to the power 1. Therefore, number of factors is actually 4 plus 1 multiplied by 1 plus 1 multiplied by 1 plus 1, and the answer is actually 20. And this is the answer. This is a possible answer. Therefore, we have to look at other cases. Because in the second case, I assume that 2n is the product of 2 primes. But 2n can also be product of 3 primes. Right? Therefore, I think we look at the last case. That means in this case, last case, case number 3. 2n is the product of 3 distinct prime, P, Q, R. That means P, Q, R are distinct primes. Distinct primes. Right? Okay, then in this case, can I assume that R is equal to 2 and then your Q is less than P? Is less than P. That means your 2n is actually equal to PQ multiplied by 2. That means your n is actually PQ. Your n is actually PQ. Then again, can I assume that R is equal to 2 and then your Q is equal to 3? Right? That means your n is actually P multiplied by 3. P multiplied by 3. Yeah. And then what is your 3n now? Your 3n is P multiplied by 3 squared. Multiplied by 3 squared. Right? Then number of factors. In this case, number of factors is actually 1 plus 1 multiplied by 2 plus 1. That means P to the power 1. And the answer is just equal to 6. And this is obviously not equal to 12, therefore not possible. Therefore, what does it mean? That means now your R is equal to 2. Yeah. And then your Q has to be greater than 3. Right? That means your PQ now is what? That means your n is actually equal to PQ. Right? And then your 3n is actually 3PQ. 3PQ. And the number of factors, would be just equal to what? 3 to the power 1, P to the power 1, and then Q to the power 1, right? Therefore, it's 1 plus 1 multiplied by 1 plus 1 multiplied by 1 plus 1. And the answer is 8. Again, it cannot be equal to 12. Therefore, again, not possible. Not possible. Therefore, I think we complete this discussion. That actually there's only one solution. That means in this case, the number of factors is actually 20. This is the answer. That means the number of factors of 12n. That means in this case, we are looking at 12n. The number of factors is 20. That's it.